This is Evan from Team Accelerate, and today we'll be going over the most commonly used hardware classes in FTC programming. These hardware classes are the DC motor hardware classes, the servo hardware classes, and the CR servo hardware classes. The most common methods you will be using are DC motor.setPower, DC motor.getPower, and if you're running with motor encoders, you'll use DC power.getCurrentPosition and DC motor.setTargetPosition. Starting with the set power method, you are able to input any number ranging from -1 to 1, and this will be the percentage of its total power that the wheel will turn at. Generally, you will want to keep this at around 0.7 for teleop functions and anywhere from 0.4 to 0.6 for autonomous functions. Get power returns the current value that has been set by set power. Get current position returns how many times the wheel has turned around in units of encoder ticks, which are determined by the hardware on the motor. Set target position just sets the target position you want to move to in encoder ticks, like get current position. A few other functions you might want to use are DC motor.setDirection. This will allow you to reverse the direction that the DC motor turns when you give it a positive value or a negative value and set power. This is useful for simplifying your code down so you know which direction each motor will turn when you want it to turn. And the last method you might want to know is DC motor.setMode. These run modes can do a variety of things, but the most useful is generally reset encoders, as this will make sure that your encoder values are back to 0 whenever you start the program. Another method for DC motor is DC motor.setZeroPowerBehavior. What this does is it changes how the motor will act when the DC motor is set to 0 power. You can have it either brake or you can have it float. The brake, as the name implies, it'll have the motor try and stop the wheel. When you give it float, the motor will let the wheel spin down without any friction on it. Onto servos, the general methods you will use are a lot simpler than DC motor. You can generally just use set position, which ranges from 0 to 1, and will go along the range of motion in a percentage, and 0% would be the start of the motion, 1 would be the end of the motion. Just keep in mind that this rotation is not a full rotation of the servo. This rotation is generally 100 to 200 degrees around. The last function is servo.getPosition, which is also fairly simple. It returns the current position set by set position. The final hardware class we'll be covering is the CR servo. This class allows your servos to act more similarly to motors, as in you can set their power, or you can get their power, or you can set their direction, all in the same way you would a DC motor.